Okay, so let's see. Okay, okay, thank you. Okay, four of you actually respond to me. Okay, appreciated. If you're okay, you actually turn on the mic to actually talk to me as well, or else I'll be very lonely over here. Okay, then chapter 5, integration. Okay, have we completed everything? I don't know. Okay, let's just continue with the chapter 5, integration. Okay, number 1, basic rule. Okay, basic rule. So A. So 1 here, if d dx of fx give you small letter f, then integrate of fx, okay, integrate of fx dx will equals to capital X plus c. Okay, by the way, if you can hear me, give me a sign. Okay, then okay, so as you can see from first rule here is integration is the reverse relationship of differentiation. So as you can see over here, whatever happened to the fx and goes to the small letter f. Okay, if you reverse the process, it gives you the fx here and the result, and we'll have an additional plus c at the back. Okay, then number 2, okay, if d dx of capital F equals to fx, then integrate of a b fx dx will give you us f of b minus f of a. Okay, this is the definition. Okay, so over here with the one with plus c, we have expression. This one we call it indefinite integration. Okay, and this one is your definite integration. Okay, then number 3, just like your differentiation, if you have fx plus minus gx here, so we can separate them. Number 4, if you have a multiple in front of fx, you can take out the multiple first. Okay, then number 5, we have if you have a constant, okay, like if you kx plus c. Number 6, if you have a b fx dx, it can be written as negative of ba fx dx. That means it can, the a and b, the limit actually can change position. Okay, then okay, so you have the first 6 basic rules here. Then after that you have b, basic integration. Okay, so just as like how I expressed to you about rule number 1 is that they are the reverse process. Therefore, the basic integration here is exactly the reverse process of differentiation. Okay, so for example, in differentiation, we for x power n, bring down the power minus by 1. Therefore, over here, we will have x plus 1 divided by a new power plus c. But over here, the n cannot be equals to minus 1 because the minus 1 at the bottom will go to 0. Hence, it becomes undefined. Number 8. So as you can see, this is exactly the reverse process of differentiation. Number 8, we have fx. Okay, ex here. So we have ex plus c. Okay, again, is exactly the reverse process of differentiation. Number 9, you have 1 over x dx. Okay, we have ln modulus x. Please understand that there is a modular sign here. Okay, number 10. Number 10, if you have a sine x, it gives you negative cos. Okay, because as we say, this is exactly the reverse process of differentiation. When you differentiate cos, it gives you negative sign. So when you integrate sine, give you negative cos. It's a reverse process. Number 11, you have a cos x. It gives you back the sine x. So if you do remember how I have taught you for the trigo, sine go to cos, cos go to negative sine goes to negative cos. This one we say that this is the order of the differentiation. Then the integration will go in the reverse position. Therefore, you can see that sine go to negative cos because it's a reverse process. This is your differentiation here. This is your integration here. Okay, don't forget they are the reverse process. So it's common that during exam, students actually forgotten the sign and actually write the rule wrongly. So if we have sine, if we have cos, of course, we don't have tangent here because this is a reverse process. But the integration of secant square is the tangent because it's a reverse process of differentiation. When we do differentiation, okay, we differentiate tangent, we get a secant square. Students are expected to remember this. For example, secant x tangent x, then give you the secant x plus c. And 14, if we have a cosecant x, it gives you a negative cotangent x plus c. Number 15, if you have a cosecant x, cotangent x, so you will have a negative cosecant x plus c. Of course, some of you may be like worried that why there are so many formulas to remember. If you think about it correctly, once you're familiar with differentiation, this one is nothing because it's exactly the reverse process. Okay. What you need to worry about is from section C and onwards. Okay. So number 16, we have an integrate of 1 over 1 plus x squared dx equals to arctangent of x plus c. Again, it's a reverse process of the differentiation. Okay, under section B, okay, the one special thing is rule 17. If rule 7 to 16, x is in linear form. Okay, my sentence doesn't sound right. Okay, the x is if x from rule 7 to rule 16 is in the linear form. Linear form means ax plus b. Okay, the x inside is actually in the linear form. So the x here, the x here, the x here, okay, the x here, the x here. Then multiply, okay, replace x as ax plus b and multiply right hand side by 1 over a. Okay, this rule is very important because it only works for you have to understand this rule very well because it only works for linear form. Okay, it only works for linear form. So example, okay, let's say I have a cosecant square of 3x plus 2. Okay, cosecant square give me negative cotangent. So I have a negative cotangent of 3x plus 2. Okay, plus c. Then we have a multiply by 1 over 3. This 1 over 3 is actually come from your the a, the value of a here. Another example. Okay, let's say you have a secant of 3x, okay, maybe ax plus b, ax plus b, ax plus b tangent ax plus b dx. Then according to the rule 13 here, rule 13, secant x tangent x, I will get a result of 1 over a of secant ax plus b plus c. Are you okay? Okay, I think I'm going to write out all the rules first. Okay, then okay, then let's say for number 8. Okay, let's say I use number 8. Number 8, I have e of 3x plus 2 dx. According to rule number 8 is one of the easiest one because it's the same thing. Okay, give you back the same thing. So but the x is not a single x, it's in the linear form of 3x plus 2. Then I will write my answer as 1 over 3 e 3x plus 2 plus c. Okay, I think I'll, or maybe can better. Okay, then I think I'm going to write out all the formulas first, so you have an idea about this topic. Okay, what are the coverage for this topic? So the A and B, of course, the section A and section B here, they are the easy one. Then section C, okay, some rules about trigo. Rules about trigo. Okay, so this is rule 18. Okay, for trigo with power more than 1, change it into power 1 using trigo formula before integration. Okay, number 19, for multiplication of 2 trigo, change it into plus minus of 2 trigo using trigo formula before integration. So if this appear, of course, we expected students to remember all trigo rules. Expect student to remember all trigo rules. Okay. So over here, what exactly happened to this type of questions? Okay. So for trigo with power more than 1, let's say I want to have a sine square x. Okay, I have a sine square x. Sine square x. From section B, I have x power n, I have ex, I have 1 over x, I have a single sine, a single cos, secant square, secant tangent, cosecant square, cosecant cotangent, but I don't have a sine square. Okay, but I don't have a sine square. From trigo formula, we want to look for something that are able to change power 2 into power 1. So over here we use cos of 2x equals to 1 minus 2 sine square x. Then from here, after I rearranging by writing sine square x as my subject, I'll have 1 minus cos 2x over 2. Okay, so you will see that the trigo already changes power 2 into power 1. Okay, then I will have the form of 1 over 2 integrate of 1 minus cos 2x dx. The rest is just integration. 1 back to the rule is 1 is a constant. 1 is the constant from rule number 5. It gives you kx. So this is just a single x. Okay, the 1 over 2 can take it out, but also based on the rule, the basic rule, the multiple. The multiple can actually take it out from rule number 4. Then cos of 2x based on rule of 11, cos goes to sine. Okay, cos goes to sine. Then 2x remain. But from rule 17, okay, from rule 17, we have, okay, we have the linear form, which is the 2x. So I need to divide it by 2 plus c. So in the end, you have a 1 over 2x minus 1 over 4 of sine 2x plus c. Okay, this is for rule 18. Okay, this is for the rule 18 here. Then, maybe I give you another example of rule 18. That if I have a sine cube power 3. Okay, again, for trigo with power more than 1, change it into power 1 using trigo formula before integration. So, earlier sine square, I used this formula of the cos 2x equals to 1 minus 2 sine square x. For the sine qx, what formula that we can use? Okay, we can use sine of 3x triple angle formula equals to 3 sine 4 sine wrongly. 3 sine x minus 4 sine cube x. Okay, we will have this formula. Okay, then by writing sine cube x as my subject, so I have a sine cube x equals to 3 sine x minus sine 3x over 4. You will see that I managed to change power 3 to power 1. Okay, I managed to change power 3 to power 1 from after I rearrange the thing. Okay, by using the correct formula. Then from here, you will see that this sine of qx I can write as a 1 over 4 of 3 sine x minus sine 3x dx. Okay, so I have a 1 over 4. So 3 sine x back to the rule. Okay, sine is here. This is just a single sine. So 3 serves as a multiple. So I have a negative 3 of cos x. Okay, so this one plus, but this one is in the linear form, 3x plus 0. So I have a cos of 3x over 3 plus c. Acceptable? Tell me. Okay, no issue, then I will continue. From 19, rule 19 say, for multiplication of 2 trigo, change it into plus minus of 2 trigo using trigo formula before integration. Okay, so rule 19. Okay, rule 19 here, let's say I have a multiple. So I have a sine 3x cos 2x. Okay, so they are both power 1, but don't be confused. Although they are both power 1, but the thing is they are both of them multiplied together. Okay, sine 3x multiplied by cos 2x. So over here, what can we do? Okay, we can actually use the formula of sine of a plus b, okay, plus sine of a minus b equals to 2 sine a cos b. Okay, then we actually can use this formula. Again, it's actually back to trigo. Remember, I keep telling you that chapter 1, 2, 3, you have to be very, very strong. Okay, because all from chapter 4 onwards, okay, we don't care already. Just okay, I will assume students know how to do for chapter 1, 2, 3, and then apply to it. Okay, so over here, how to actually use this? Okay, I will read this form as a sine A cos B. So okay, although I'm missing a 2 there, but the 2 will be shifted to the other side. So according to rule 19, for multiplication of two trigo, change it into plus minus of two trigo using trigo formula before integration. So before I do my integration, I have a 1 over 2 of sine of 3x plus 2x plus sine of 3x minus 2x dx. Okay, then I will have a 1 over 2 of integrate of sine of 5x plus sine of x dx. Now it's being very nice. Okay, it's already in a simplified form. Okay, just a single sign. Okay, and is in linear form. Therefore, I can do my integration immediately. So by using section B formula, negative 1 over 5 cos of 5x minus cos of x plus c. Done. Finish. Okay. Then this will be rule section C. Okay. So in order to help students understand the entire topic, I will write out all the formulas first. Okay, let me write out the remaining sessions. Okay, without explaining. So D, I have advanced formula. Okay, this is 19, then this is 20. 20, I will have a integrate of f prime x fx r dx equals to fx r plus 1 over r plus 1 plus c. 21, I will have f prime x e fx dx equals to e fx plus c. Number 22, I have f prime x fx dx equals to ln of fx plus c. Number 23, I'll have a rule 22 with partial fraction. So that means we are expected students to know how to apply the algebra to do the partial fraction. Okay. Then after that, we have after section D, advanced formula, we have E. Okay, special formula with proof. Okay, so special formula actually as a previous question that actually appeared in the exam before. So for example, we have sine 2x sine square x dx equals to 1 over 2 x minus sine x cos x plus c, or sine of square kx, okay, equals to 1 over 2 of x minus sine kx cos kx over k plus c. 25, we have a cos square x dx equals to 1 over 2 of x plus sine x cos x plus c, or we have integrate of cos square kx dx equals to 1 over 2 of x plus sine kx cos kx over k plus c. 26, okay, integrate of ln x, we have x ln x minus x plus c. Number 27, we have an integrate of tangent x equals to ln of modulus secant x plus c. 28, we have cotangent x dx equals to ln of sine x plus c. 29, we have secant x equals to ln of secant x plus tangent x plus c. 30, we have a cosecant x equals to negative ln of cosecant x plus cotangent x plus c. Okay, number 30, 1, 2, 3, 4. Okay, then I have, this is section E. Then section F, integration technique. Integration technique. Okay, so 31, we have a separating variable, okay. So 32, I have the by parts. Okay, oh sorry, this is separating variable should be number 33. 33, 31 is by substitution. Okay, this one is become technique. So your exam question will be focused on F. Okay, your exam question will be focused on F, because when come to F, right, we assume students already know the previous 30. Okay, when come to F, we assume students already know the previous 30. So this is integration technique. Then number G, okay, section G, we have application. Okay, so 34, trapezium rule. This one you can ignore. This one is no longer in the syllabus, but just to tell you, okay, just to write it down here so that you actually know there's such things there. Okay, then 35, you have a area by x. So we have a x1, x2, y in terms of x dx. This one you are very familiar, okay? But you also can have a parametric equation form. So y in terms of t, dx, dt, dt. Okay, 36, you have area by y. Okay, you have a y1, y2, x in terms of y dy equals, or in the parametric form, you have t1, t2, in x in terms of t, dy, dt, dt. Okay, or we have the volume formula, 37, volume by x. So we have a pi of x1, x2, y x in square dx, or in the parametric form of pi of t1, t2, okay, y in terms of t, the whole thing square, dy, no, dx, dt, dt. Then, or 38, volume by y, we have a pi of y1, y2, x in terms of y, square dy, or pi of t1, t2, okay, this one x in terms of t, square dy, dt, dt. Okay, application. Then we also have FGH extra. Okay, extra also serve as a question that appear from the past. Okay, extra we have integrations of a power x dx will give us ax over ln a plus c. This is different from bring down the power minus by 1, then or maybe log of ax for any base. Okay, it will be 1 over ln a of x ln x minus x plus c. That one, of course, we will deal with this later. Okay, so over here, these are the entire 40 formulas for chapter 5. Okay, but for practices definitely it will take some time. Okay, but the practices definitely take some time. Therefore, today we focus on the base section A and section B. Okay, section B, A, and section B. Let me highlight to you again section A. Okay, if ddx of capital F equals to ff, then integrate of small letter f equals to capital F plus c. This is called indefinite integration. Okay, it's a reverse process of your differentiation. Number 2, if differentiate of the capital F equals to small letter f, then with the limit of a to b, it will be f of b minus f of a. This is called a definite integration. Number 3, if we have a plus minus in between, we can always separate them before we do our integration. Number 4, if I have a multiple, I always can take out the multiple before I do my integration. Number 5, if I have a constant, I will have a kx plus c. Number 6, I have a to b. They can change positions as with the negative, a b below, a above. Then section B, okay, section B basic integration is exactly the reverse process of differentiation. Number 7 is the power plus 1 over power over new power, where n is not equal to negative 1. Okay, number 8, ex go back to ex. Number 9, 1 over x goes to ln x. As you can see, all you need to do is just remember the differentiation part. You can always go backwards. Okay. Then 10, we have a trigo. The sine goes to negative cos. Then 11, cos go to sine. I already explained to you from the process over here. Okay. Then number 12, 13, 14, 15, they are exactly the reverse process of your differentiation. Your 12, differentiate of tangent gives you secant square. 13, differentiate of secant gives you secant tangent. 14, differentiate of cotangent gives you negative cosecant square. 15, differentiate of cosecant gives you negative cosecant cotangent. Okay, 16, differentiate of arctangent gives you 1 over 1 plus x square. What important is rule 17. Okay, so rule 17, if you are able to do, okay, this in the linear form. Okay, what I already show you some example over here for the linear form. Therefore, I think the best is to let you do the question. Okay, wait for me. Let me open up the questions. Okay, let me open up the questions so that you actually can practice. P3. Okay, I will let you practice section by section so that you are not so confused about the rules. So today we will focus only on section A and B. Okay, so only on section A and B. Okay, then this one. Let me crop the answer as well. Okay, this will be your work for today. Okay, for section A and B. Any question you want to ask?